So hello friend, welcome to my channel. So today I am going to discuss about the pericyclic reaction. This is basically a revision class because today the CCIR exams date announcement has come. So exam will be held on November of 19 and 21 and 26 like that. So in 3 shift exam will conduct. So okay, so keeping all things into our minds, so we will go through the fast in revision so that we can easily cover all things and complete in on times. So this lecture basically the pericyclic reaction based lecture, and here I am going to the discuss about in short way. Basically it is a revision class, and guys, if you have not subscribed my channel, so please subscribe the channel and click the bell icon so that you will get easily notification when I upload the videos, and share with your friends and comments and likes. Okay, now I will start. So what is pericyclic reaction? So it is basically the going to discuss about pericyclic reaction. Pericyclic reaction. So what is pericyclic reaction? If you see this word pericyclic, it is means of the around the circles, and it comes from the cyclic shifts. So it is a concerted reaction, and with cyclic shift of the electron. Okay, cyclic shift of electrons. Okay, and in this reaction, reactants bond broken and product bond formed. Okay, so means parallelly the reactant bond broken and product bonds formed. So at the same times transition state will form. So here it does not form intermediate but form the transition states. So does not form intermediate but form transition state. Okay, so we take the reactions, and this reaction happen under thermal condition as well photochemical reaction, H mu lights. Okay, if you took the examples like this, so it will like this, it will go like this. So under heat condition it will form this product. Okay, so this is the wheels basically deals and direction. Okay, and if you see this another example, see this is basically a ring closure. So it is basically a ring closure. Okay, so like this, ring closure. And this last example in reaction. This is the in reaction. This in reaction. So like this, this Pericyclic reaction will happen. Okay, so now there are two pi molecular orbitals. One is highest occupied molecular orbital, second is lowest occupied unoccupied, which is basically we know the HOMO and LUMO. So HOMO LUMO is basically, if we see in this ethylene molecules, CH2 double bond CH2, then we see here numbers of carbon is 2 and numbers of pi electron is 2, numbers of node is n-1. so if we see this is for psi 1 and this is for psi 2. Okay, so n बराबर 0 nodes plus n बराबर 1 nodes plus minus. Okay, so if we see under heat condition, so here 2 electrons in grounded state and this is HOMO, this is LUMO. Okay, and under, if you see under light condition, this electron goes to like this. Okay, so this become HOMO. Okay, under HMU condition, this is for thermal condition and this is for photo condition. Okay, so this is LUMO, this is HOMO. If we took example, another example 1,3-butadiene then same thing will also happens here. For the case of 1,3-dibutadiene, we will draw the 4 energy level, and psi1, psi2, psi3, psi4, and we fill the 4 electrons, because 4 pi electrons is total electron is 4, so we fill the 4 electrons. And in excited state, means in HMU condition, 1 electron goes to highest energy state, become HOMO. Okay, so like this, some basic introduction about the pericyclic reaction. There are some classification of two independent symmetric properties, like one is symmetric molecular orbital, we can say the mirror image plane, and second is C2 symmetric. Okay, this molecular orbitals, M symmetric means plane of symmetry, and this mirror plane perpendicular the plane. Okay, so now I come to the types of, so before going to types of pericyclic reaction, I will show some classification of independent symmetry. One is like symmetric molecular orbital, another is, here we see the, if you draw this, so M means mirror plane, so this will be minus, this will be minus, and this will be plus, this will be also plus. Okay, so this is for M. Okay, now for C2, if you see for C2 case, C2, here I will show you for C2, second for C2 symmetry, so just difference like this. So here will be plus, here will be minus, here will be plus, minus, here will be plus, so like this. C2 means center of symmetry. Okay, not mirror plane. So this is for C2. So this is basic introductions about symmetry. Now I'm going to discuss about types of pericyclic reaction. Types of pericyclic reaction. So there are basically clearly okay, types of pericyclic reaction. So there are basically 4 types. One is electrocyclic reaction, second is cycloaddition, reaction. Third is sigmotropic reaction. Fourth is group transfer. Okay, so one by one I will give some little bit information. So first we will discuss cyclic reaction. So what is electrocyclic reaction? It is basically the ring closure or ring opening, and it undergo HME, it under or HME. Okay, and under this condition reaction goes like ring opening or closing. Okay, it means that sigma bond form across conjugated system. Okay, right. So if we see example, this see it here HME condition, so it will go like this and form this. Okay, so this is basically the ring closing. So here the loss of pi bond and gain of sigma bond formation, because here the formation of sigma bond and loss of, there are two loss of pi bonds. Okay, so now if you see the ring opening, so here it under HME condition. So if we break like this, so it will form like that. So this is breaking. Okay, ring opening system. So this is basic introductions about electrocyclic reaction. So here basically ring opening or ring closing happen, and gain of, here's gain of sigma bond and loss of pi bonds. Okay, now I will give summarize tables, which is very very important exam point of view, and you should remember these tables. So if we system, heat and HMU, so 4 pi and systems under heat condition it will be conrotatory, and under light condition this rotatory, and 4n plus 2 pi system under heat conditions it will be this rotatory, and the light conditions will be conrotatory. So just opposite to each other. Okay, This you should remember table, because this is very important during solving the problem. And one more things you have also remember. Okay, so if in reactants having some ligands, like if in reactants having first, we can, this is different from tables, you should also remember these things. First, if cis and cis things in your reactant, then all over becomes cis. Okay, if trans, then all over become cis. Okay, I will tell you and explain in next. I mean in further I will explain in detail. First you write these things. And third, if cis trans, then our overall will be trans. Okay, and fourth, just a positive, trans and cis, then overall trans. So what is application of these things? I will explain you how these things is happens. Okay, so it is basically something directly you will get the answer. How you will get answer? This is some trick. If overall cis, you will get in reactant overall cis, and in your condition is like this 4pi n system under heat condition can, then if overall your reactant is cis, I am giving example, cis, overall your reacting is cis, and your system is 4pi n system under heat condition, means can, then this will change, means change to trans. So it is gives the information about stereochemistry. Okay, and if this is this, then there will be no change. Okay, only change if cone condition is applied. Okay, I will give one example there so that you can easily solve, easily understand what I am trying to explain you. Okay, okay, now I will tell you what is the application of that things which I have told to you. So if we see in examples, these examples. If you have these examples, okay, and you have methyl here and one hydrogen here, another hydrogen here, you have methyl here. So this is trans, this is your also trans, okay. And under heat condition, because this is the 4-pi system, under heat condition, so you have to apply con. If you go what I told in earlier, con condition, so it will change. So stereochemistry, it will change. So it will be like this. So here the methyl will go like change, means here is all over trans, means we can write the cis. So overall layer cis, okay, trans, so overall is equal to cis. So cis converted to trans. So here the stereochemistry will be trans. This is above the plane, this is below the plane. So here this is the basic application what I was trying to earlier, means trans is equal to all over cis. So here is the applications, okay. Hopefully you understood what I am trying to explain you, okay. So if you similarly, if you see similarly another examples, this H here methyl, H here methyl. So here you will see trans, here you will see cis, both hydrogen in same side. This cis trans, what I told you, cis trans all over trans. So trans, this is 4-pi system. So 4-pi system under heat condition, con, so con all over trans become cis, okay. So stereochemistry will be cis, okay. So these both are in same plane, okay. So this become cis stereochemistry. Here is trans stereochemistry. So I hope you guys understood clearly, okay. So like this example you can easily solve by using this trick, okay. Now I move to next things, okay. Next things is cycloaddition. Second, cycloaddition. Second I will discuss cycloaddition. Cycloaddition reaction. So what is cycloaddition reaction? Cycloaddition reaction, it is basically the two unsaturated molecules undergo addition reaction and gives the cyclic product. The formation of this cyclic product takes place through loss of pi bond, means 2 pi bonds, and gain of 2 sigma bonds. So here also loss of 2 pi bonds and gain of 2 pi bond, sigma bond take place, okay. So if you see examples, and this reaction is will go under means heat, means first like for 4 pi 2 systems go under heat thermal condition, okay, but 2 plus 2 system go under HMU condition, photochemical condition, okay. So if we see examples, these examples under his 2 plus 2, so form this. So here is 2 1 pi and 1 pi, 1 sigma 1 sigma, so here 2 pi is lost and form this one and this one sigma bond. So here is 2 sigma bond gain and 2 pi bond so loss. So this is the statement holds for these examples, okay. Now I will give some introduction about the here the molecular energy level diagrams of these diene and dinophiles. So for 4 pi 2 systems like this, so this will go under heat condition, thermal condition. So in cycloaddition here they clearly says the 4 pi plus 2 system undergo thermal condition and 2 plus 2 system undergo light condition, HMU condition, okay. So this is diene, this is dinophile, okay. Under heat condition this will form product 4 plus 2 means 4 plus 2 under heat. I told you what will be the dish rotatory, it will be the dish rotatory, under go dish rotatory, okay. So and if we see these things, and one thing I will tell you some. So here I some points, note points. Supra interaction is superficial addition. Supra okay, supra interaction called the superficial addition, okay. But supra intra just opposite interaction called the intrafacial addition, okay. Interfacial addition. So I will give the examples of this so that you can easily understand what I am trying to explain. So if you as I told you here, diene, this is react under homo condition, and this is LUMO, this dinophile. So if we draw the energy levels, so for diene, see like this. So here is 4 pi electrons, so 2 electron goes here, 2 electron goes here, and this is psi 1, this is psi 2, this is psi 3, this is psi 4, and this is HOMO, this is HOMO, this is LUMO. Okay, and this is M symmetry, this is C2 symmetry, this is M symmetry, this is C2 symmetry. C2 symmetry means if we, this is diene for the case of diene. Okay, and if you see for dinophile, so here only 2 electrons, so this is for HOMO. Okay, ground state, and this is LUMO, excited state, excited state, LUMO. Okay, yeah, correct. So this is ground state, this is excited state, and this is dinophile. Okay, so what I am trying to explain you here, so how supra and intra will interact during this diagram. So here I told you supra means HOMO. So if you took HOMO of this and LUMO of this, so HOMO of this means so here the basically 4 carbon, for diene 4 carbon, so 4 orbital, p orbital will form. Okay, so like this. So for psi 1 there is 0 nodes, so all above are positive, so this will be the M because each 2 orbitals are mirror image to each other. Okay, and for psi 2 it will be the 1 nodes, and for psi 3 it become 2 nodes, and like that psi 4 become 3 nodes. So if you took HOMO of this psi 2, so HOMO of psi 2 means center of symmetry. This one be plus, this one be negative, this one be negative, this will be plus. Okay, this is for diene HOMO, and this is LUMO. Here the minus, here the plus, here the plus, here the minus. So this interaction form the bonding. Okay, and this interaction also form the bonding. So this is basically supra means positive we call the supra, and negative called the supra also. So this is both are bonding interaction. So this is the main application of this supra and the interaction. So and if we reverse the this condition also, we can get the supra interaction. If we here change like this, for diene if we take LUMO, and for dienophile take HOMO, then we will get same structure like this. So for diene LUMO means you will get this M plus, okay. For diene HOMO, this is also M. So MM means say negative, positive, so this will also interact. So this is diene, this is dienophile. So we can also interact like this manner. So two way we can so two possibility, which is interact suprafacial interaction. Okay, now I will discuss about the some notes which is very important. Okay, directly you can solve the problem. Okay, so what is the notes points which is you can directly solve the problem. So note is basically I am giving to, this is not notes, you can say the trick one. Trick one is what trick one says. Trick one says if both methyl group which are basically attached same side, basically same side, then stereochemistry will be would be same. Okay, stereochemistry would be same. And if we see through examples directly, see example, here H, here methyl, and this is double one, and this react with this. This is just this CO carbonyl methyl. So what I am saying to here, so this both hydrogen is right side, you can say right side, this is you can say both methyl group left side. So here the symmetry will be same, or it will be the above the plane or below the plane, and here will be the difference because both here this hydrogen is opposite sides. So here will be the the difference. So what will be the this 4 plus 2 addition, 4 plus 2 addition under heat condition. So 4 plus 2 under heat condition is mixed to this rotatory. This rotatory means the product form like this. It will go under like this, it will go like this, and it will go like this. So here it will get the double bond. So I am saying the stoichiometry for this carbon, so for this carbon stoichiometry will be same. It will be above the plane or below the plane. So we can write above the plane, so here the methyl, so here the methyl, okay. But the stoichiometry will be changed for this carbon, both carbon. So it will be first one be the below the plane, C double bond O methyl, and this will be the above the plane, okay. So this is the points I am trying to so